Hello everyone, my name is Joshua Tieno, and today I would love to take you through one of the laws of mortality. We have two laws of mortality, and the first one is Gompertz, and the second one is Markham's law of mortality. And today I'm using a software called LaTeX because LaTeX has these features of mathematics, and they can be seen and be visible. They can be clear, and it's very easy to use and display my workings here with you. So if you don't know how to use LaTeX, don't panic. The aim of today's lesson is to just grasp the concept, a step-by-step derivation, of the Gompertz law. And the Gompertz law itself, you can be asked a question that states that show that Gompertz law holds for all ages alpha, where alpha is always our index, the lowest age that we can be doing study as actuaries and students. So actually the law always states that the probability of survival of a person aged X, this is actually the probability of a person aged X, currently age X, surviving to the next T years, is given by this G raised to C to power X into C T minus 1. So I will love to take you step by step to derive this formula. So first of all, Gompertz, we know that Gompertz, what we should put in our mind before we start this is that the probability of survival, TPX, the probability of survival is always given by it's always an exponent given by exponent negative integral from 0. Actually, we have one error here, we have one excess. From negative 0, from 0 to T of mu x plus T, of mu x plus T. So this is what we know from our basic concepts in actuarial science. So we want to apply this there. So in Then in Gompertz law, the force of mortality mu in Gompertz law, the force of mortality mu x, the force of mortality mu x, the force of mortality mu x is given by capital B c to power x, c x implying that so according to Gompertz law, the force of mortality is given by this. So this implies that it implies that we will have the mu x plus t, because mu x plus t is what we have there, and what we have there, let me place it here so that can be visible. The t should not be so huge. So the mu x plus t, this implies that the mu x plus t, let's copy that, the mu x plus t should be given by, let's copy that, bcx plus t. Copy that. Okay, so this implies that mu x plus t will be given by bc raised to x plus t. So let us replace it back. Let us take that bcx plus t and replace it back here, and replace it here. Here where we have our mu x plus t. So we'll have basically, we'll take this, copy, we'll paste it here, then we will change this one to bcx plus t. Okay, copy. We're only replacing mu x plus t with bcx plus t, and that gives us that. So we will have the probability of survival being equal to that. So, and we are integrating with respect to t. We will be integrating this with respect to t. We are integrating with respect to t. So we are integrating with respect to t. So here, what we will do here is now to soften this so that we can see the constants. If you can see here, we have a constant b and we have a constant c, because we have two c's here. We have the same base but different powers. So we take these ones, the constants will be out. We take the constants out. So let's take the constants out. Let's take the constants out. Oops. What have I done? Let's take the constants out. We want to take the constants out. Sorry. constants out. If we take the constants out, let's now take the constants out. The constant is let's take this b cx out here. So have that here. So we'll be integrating. That will be integrating 10. So why is it doing an error? Let's see for the error. Integrating from there to that. There is an extra this. So okay. So we'll have this one to be removed. Let's remove that. Okay. So after removing the constants out, we remain with that. So we want to integrate this one using calculus. Calculus 2. This is integral calculus. Integral calculus states that when we are integrating this, okay, when we are integrating that, we are supposed to get, when we use our tables, we will get that this one is given by we will have c raised to t, c raised to t, c raised to t, then all over log c over log c. Yeah, so as you can see here, okay, this is dt. Where is it? dt. So when we integrate this with respect to t from t to 0, we will have this one. Then we will substitute our limits, and our limits is will be 0 to t. So that's our limit. So we substitute our limits here, 0 to t. So when we substitute our limits, it implies that we will have, let's equate, we will have, when we substitute, we have integrated this with respect to t. So where we have t, we place our limits. So we start with the highest limit, which is t. So when we place t where t is, we will have c, we'll have it the way it is. Okay, it will remain the same. Let's copy that. That's it. It will remain the same. Then when we have 0, we will subtract. When we have 0, the c this c here, when we place 0 here, we will have actually a 1 there, because c, anything raised to 0 is 1, so we'll have a number 1 there. So we will be having something like that. So we will be having this one minus this one. So we have it giving us the same answer. The answer will be, when you do, because we have the same base, the same denominator, so what we do, we place them under the same fraction, we simplify it, place it under the same fraction, we have one fraction, so we'll have c raised to t, c raised to t, c raised to t, subtracting 1 all over log c. So this is what now we have. From what we have, oops, that should be 1. Okay, now yes, yeah, it should be that way. Now from what we were doing up here, from what we were doing up here, we can see easily that we've now integrated this part and formed this solution. So we are supposed to take the solution and replace it here. So what we do, we take copy, B, then we replace this integral part by this copy, so we replace it back. Oops, we have an error. Where's our error? We are missing this. Let's just begin it with the exponential. Oops, the one for exponential is missing. Let's place it there. Shift. So I think we are done. It should be running. Yeah. So this is what now we have. This is now what we were looking for now. So at the moment we have already gotten almost everything and every bit of it. So we are almost done. We are now done. When you are just here, what is remaining is to substitute something small. Something small is remaining. So this moment it's so let's see. I want to write this equation because the log is dividing the whole part of this part. The log is dividing the whole of this expression up here. We can as well place it under some b here. So let's copy this first and place it over b, so that let's see, so that we can simplify it to have something like that, something like this. We want to simplify it to have something like that. We want to separate this part from this part. So I want to take this c, multiply by the numerator here, then have this one below b. So let's copy and paste there. Then we are taking this log under b. So what do we do? Take this one, copy it, place it here now. Shift to b, take b, take negative b. Let's have this one selected. an error. Should we have an error? Exactly. So we have an error. So this error is occurring due to this. Place that on there. So it should be running. So yeah, we have placed it now where we want it. So when you reach this place in Gompertz, when we read our books, Gompertz states that that G that you're seeing there, the G that you're seeing there, that G is always equal to exponential exp exponential shift sub that we have exponential exponential negative b over log c. Negative b over log c. That's log c. So what we are remaining with here, oops, we have an error. We have undefined control. So what is that? That is undefined. Okay, yeah. So that is our G. So what we do here is just to replace that, and then we are done. Simple question. Just simply that way. So we want to replace our, we have to replace it till this part. This part is being replaced by G. Yeah, and we are okay. We have another error, an extra. So where's that extra? We don't have that. So where's that one coming from? Yes, now we have solved it and we are done. So at this point we are done. So for more derivatives, I'll be doing another video in the other law, that is Markham's law. So this is what we have actually derived, and we have. So thank you for watching, and let's meet in the next lesson. Thank you. Follow, don't forget to follow, like and subscribe to my channel. Thank you.